Hello guys, this is Sir Franz again, and in this video, we will be learning about parabola. Yes, you heard that clearly. We will be talking and be discussing about another type of conic section, which is parabola. Here we go. Okay, so I'm going to flash here the definition of terms, so you can pause this and uh, copy this on your notes or write it down in your notebook or whatever you're using right now. So let me read it for you. Parabola is the locus of all points in the plane whose distances from a fixed point and from a fixed line are the same. So the fixed point is what we call the focus, and the fixed line is what we call the directrix. Focus, which is the fixed point denoted by big letter F, the parabola always devours the focus, which means it's always within the parabola. So the focus and then the parabola should be going down. The fixed line, which is the directrix denoted by I, the parabola always, no, big letter L, the parabola always opens away from the directrix. Yes, basically, the parabola always open away from the directrix. They're not really that close. So the directrix is always at the back portion of the parabola. Well, the focal length, which is the distance from the vertex to the focus denoted by P, or absolute value P, where P dictates the opening of the parabola, and the latus rectum, a segment that is parallel to the directrix that passes through the focus whose endpoints is on the parabola. So if you call a latus rectum, so it's okay. I'm gonna show you here a drawing where you're going to uh, see and identify which one or which is the terms being described. For the vertex, it is the point on the parabola closest to the focus and determines the maximum and minimum value point of the parabola, denoted by big letter V. And for the axis, it is the line that passes through the focus and the vertex, which is perpendicular to the directrix, or you can also call this one the axis of symmetry. So let me show you here. Okay. So let's say we have, suppose this is our fixed line, which is the directrix, and up our fixed point, which is the focus. And let's say this point here is a point within the parabola. Or let me say this is our, let's assume this is our vertex. So vertex H and K. And this will determine the parabola's characteristics, whether how it will open. So I plotted here some points to complete the parabola. And suppose we already have the parabola here being graphed. So I'm so sorry, I'm just using here an MS PowerPoint. So basically, I don't have guidelines in doing, I mean, lines or grid lines in doing this one. So this is supposedly a parabola form, okay, like a letter C. Next, it was mentioned there in the definition that the distance from the fixed line to the vertex is equidistant to the distance from the fixed point or from the vertex to the fixed point, which means this this line is equal to this line, or this distance is equal to this distance, denoted by P. So if this value here is P, then we also have another P here. Next. Same goes with the other points on the parabola. So from the fixed point to your vertex and from the directrix to your vertex, they are just equidistant to each other. and also the other points. So let's assume, okay, this distance is equidistant. So there's something wrong with my line. So let's just assume they are equidistant. Okay. Okay. And then this line here I draw is the axis. And after that, we also have the latus rectum. Mhm. So basically, from the definition, the distance of our latus rectum is basically 4p, and from the focus or the fixed point going to an endpoint, which is this point here, that is basically measured as 2p. So when you add them, 2p plus 2p, that's 4p, and that really satisfies the definition where R1 and R2 are the endpoints of the lattice rectum. Okay, I labeled here R1 and R2. R2. So these points here are the ends of the lattice rectum or endpoints of the lattice rectum being shown. So basically, this is just an assumption of the graph, okay? So actually, this is not a perfect graph as I've shown you. So I'm going to show you some of the graph using the Desmos graph, okay, by answering an example. Okay, but before we proceed to our example, let's just first identify the properties, okay, or what are the types of parabola. First, the first type here is the vertical parabola. For the vertical parabola, we only have two options for its opening, whether it's downward or upward, okay? And has the equation in standard form, which is x minus h quantity squared is equal to 4p times the quantity of y minus k, where an arbitrary point hk is the vertex. And take note, if the vertex is at the origin, which is 0, 0, then the equation in standard form is, okay, look at this one. X squared is equal to 4py. Okay, I would like to tell you this one. In order to identify whether an equation or a given equation is a vertical parabola, all you need to do is look at the equation. As you can see, for the standard equation, it always starts with letter x or with the variable x. And since it started with a variable x, you can identify, oh, this is automatically a vertical parabola. Same goes when when the vertex is at the origin. It will start with a variable x. And if the equation is jumbled, okay, so look at the variable which is squared. As you can see, the value of x will always be squared for the vertical parabola. So you can still rearrange that one if the uh, terms are jumbled. And then P in the equation dictates the opening of the parabola. Yes, you need to take note for this one, guys. This is a very important property. If P is greater than 0, then the parabola opens upward. Mhm. If P is less than 0, then the parabola opens downward. And the focal length, which is the absolute value of P, is the distance from the vertex to the focus, as well as the distance from the vertex to the directrix, based on the definition of parabola. Therefore, vertex is the midpoint between the focus and the point of intersection of the directrix and the axis. Mm. And now the second type, which is the horizontal parabola. And yes, you can simply say for a horizontal parabola, the variable y will always be squared. As you can see, same goes with the vertex at the origin. It is y squared here. So we have the horizontal whose opening will either be right or to the left, to the right or to the left. And it has the equation in standard form. The quantity of y minus k squared is equal to 4p times the quantity of x minus h, where h and k is the vertex. And if the vertex is at the origin, then the equation in standard form is y squared is equal to 4px. And the same Okay, but a different property. If P is greater than 0, then the parabola opens to the right. Mhm. So facing all the it's facing all the positive value of your x. And for P is less than 0, then the parabola opens to the left. So it's devouring, or so like this. It's devouring all the negative values of the x. So the focal length, which is the absolute value of P, is the distance from the vertex to the focus, as well as the distance from the vertex to the directrix based on the definition of parabola. Therefore, vertex is the midpoint between the focus and the point of intersection of the directrix and the axis. Yes, basically we're still here from the properties, but you need to take note for these properties, okay? This is very important, guys. Now, let me have you hear the summary. So for a vertical parabola, the standard form of equation will be this one if our vertex is at hk, and this one also if the vertex is at 0, 0 or origin. So it's very easy to determine. And for the general form of equation, as you can see, ax squared plus bx plus cy plus t is equal to 0. And for the horizontal, the general form here will be ay squared. So as you can see, the y squared will always be squared. And for the vertical, the x the x squared will always be squared. So I'm so sorry. For the horizontal, the general form, the y variable should always be squared. So that's what I want to emphasize. Same goes with the standard form. The variable x of the vertical parabola will always be squared. And for the horizontal, the y variable will always be squared. Okay? You need to familiarize that concept. Now let's try here example number 1. Given the quantity of x minus 2 squared is equal to negative 12 times the quantity of y plus 2, find the vertex, the focus, the directrix, lattice rectum, and endpoints of the lattice rectum. Okay, basically I have here we have here a detailed explanation. Given the equation above, we can say that this is a vertical parabola. Why? As you can see, the x variable is squared. Determine the value of p so that we can identify whether the parabola opens upward or downward. All we need to do for that is to equate 4p by 12. So as you can see here, this is the 4p, right? From the standard form of the equation of a vertical parabola. So we have P is equal to negative 3. Sir, how did you get negative 3? Remember that this position here is the 4P. So you equate negative 12 to 4P. 4P is equal to negative 12. And then find the value of P by dividing it by 4. So negative 12 divided by 4, that's negative 3. Okay, if you want me to show that one, so this is how we do it. Okay, we equate uh, negative 12 by 4p. And then divide both sides by 4. Then you cancel out 4 here, and then p is equal to negative 3. So that's how it is being shown. Next. So we have p is equal to negative 3 since p is less than 0. So therefore, you can now determine the opening. That means the parabola opens downward. It's focal length P. So if you're going to measure the focal length, so you need to find the absolute value of your P. So the absolute value of negative 3, that's 3 for the focal length. Okay, let's proceed. Okay, based from the given, guys, we can identify the vertex. Yes, because it is in here. We have H here and we have K. So H is negative 2. I mean, H is 2. And then your K is negative 2. And for the focus, that is 2 and negative 5. Sir, how did you get the focus 2 and negative 5? Okay, all you need to do there for the focus, you need to copy. Since this is a vertical parabola. So what will be the value of your h? So that will always be the value of your x for the focus. And sir, how did you get negative 5? Since in our equation here, the value of k is uh the value of k is negative 2, yes. And after that, you're going to uh, add the focal length. As you can see, we have the focal length 3. So plus 3. So we have there negative 5 since it's going down. So negative 2 for your y. Okay, this is the y. Okay, let me show it this one to you. Okay, let me draw. So if this is our x and y plane. So this is y and this is x. So basically, since the vertex is located at 2, negative 2. So 1, 2, 1, 2. This is 2, negative 2. This is our vertex. And then for the focus, yes, we need to stay at 2. And how did we get negative 5, 3, 4, 5? It's all because since we already know that it's opening downward, so you just add 3 units from your negative 2. So this one, 1, 2, 3. So this will be our focus. Yes. Basing from the definition, right, that the focal point from the vertex to your focus uh, is equal to the uh, also the distance from the vertex to your directrix. So basically, this is the focal point or the value of P. And we already solved the value of P, which is 3. Absolute value of negative 3, that's 3. Okay, so that explains the value of negative 5. And then we can say that the directrix is y is equal to 1. Sir, how did you identify y is equal to 1? Just the same. Since our vertex is located at 2, negative 2, you're going to move above. Sir, why did you move above? Okay, so let's say again. Okay, I'm so sorry. Let me graph it again. So this is 2, negative 2, and then move 3 units. 1, 2, 3. So basically we have 1 here. So our directrix is located at this point. So if you're going to draw that one, so basically this is our directrix. And then 3, 4, 5. So this is our focus. This is our V. So they are equidistant from the vertex. The distance of your focus from the vertex and the distance of your directrix from the vertex are just equal or equidistant. Yes, so that's 3 units from the vertex. That gives the answer of y is equal to 1. And for the lattice rectum, sir, y is equal to negative 5. I'm sorry. How did you determine, sir, that the lattice rectum will be y is equal to negative 5? Because basing from the definition that the lattice rectum will always pass the focus. So since our graph is like this, and then so it will so let me graph it for you. So this is our vertex. So this is the graph. This is how the graph look like. And then it will always pass on the focus for the lattice rectum. I'm so sorry, it's very bold. Okay, let me clear this one. So basically, oh, why is it very bold? So yeah, that's how it was being explained. That the lattice rectum will always pass at our focus. And since our graph is opening downward. So we can simply, uh, so let me show it to you again. So we have 1, 2, and 1, 2, 3, 4, 5. So we have here our vertex, 3, 4, 5, our focus, and then 1. So we have here our directrix. So in graphing this one, guys, you need to be careful in graphing this one, okay? And then after that, you can now say that the lattice rectum y is equal to -5 because it will always pass to your focus. So let's say this is the assumption of the graph. And then the lattice rectum should be this one. And then we will identify the ends of the lattice rectum. How are we going to do that? Okay, so here below, if y is equal to -5, substitute it on the equation. Since we know that y is equal to -5, we substitute it to our standard equation. So we have the quantity of x minus 2, quantity squared, is equal to -12 times the quantity of y plus 2. So we need to change uh, y into -5. And we will now have the quantity of x minus 2, quantity squared is equal to -12. Okay, actually there should be, it's -12 times our value, which is -5, and then plus 2. And after that one, -5 plus 2, you get -3. So you perform the operation, -12 times -3, you get positive 36. Sir, why is it positive 36? Because a negative number multiplied to a negative number, that's basically positive. And then you copy here, the left format will just be the same. And since this is 36 and we need to find the value of our x, right? So finding the value of x, you need to square it both sides. Because when you square it both sides, you're going to cancel out there the square. Because the square cancels each other. And then let's proceed. What the remaining expressions will be the quantity of x minus 2, which is equal to positive -6. And after that, you have the value of x. The value of x will be 2. That's positive and then -6. So in order to find the value of x, you equate it. So x minus 2 is equal to 6 for the positive. X is equal to 6 plus 2 because it's like the positive when it is transferred here, it will become negative. So that's how we learn it. But basically, it's the addition property of equality. So 6 plus 2, that's 8. And then for the -6, x minus 2 is equal to -6. Then x is equal to -6 plus 2, that is -4. Therefore, the endpoints of the lattice rectum are 8, -5, and -4, -5. Sir, we want to see the graph of that. Okay, I prepare here the graph from Desmos graph. So basically, this is the graph, okay? So you can copy the answer there and then observe if the points are plotted and the line of the directrix is also plotted in. So this is how you're going to observe the graph of that standard or of that equation given. Next, example number 2. Consider the equation 2x squared minus 10y plus 8x minus 12 is equal to 0. Okay, look at the general equation, guys. Remember, the variable x here is squared. Therefore, we can say that this is a vertical parabola. Put this equation into standard form, or we convert this general equation into standard form. Before we can determine the vertex, focus, directrix, lattice rectum, and endpoints of the lattice rectum. Okay, here is the detailed solution, guys, below. So in order to do that, you need to divide both all over 2. You need to divide it all over 2. So dividing 2 divided by 2x squared divided by 2, that's x squared. Negative 10y divided by 2, that's negative 5y. 8x divided by 2, that's 4x. Negative 12 divided by 2, that's negative 6 is equal to 0. Since 0 divided by 2, that's 0. And after that, you regroup them. Sir, what do you mean by regroup? The value of the terms with value of x must be grouped together, and the terms with the value of y must be grouped together. Okay, since this is not a y, we can group that one. Basically, the only thing we can regroup there is the x. So we can regroup them. Okay, so let's do the regrouping. So here we go. X squared plus 4x, and then is equal to 5y plus x. Sir, is it okay to regroup 6 to x squared plus 4x? Yes. Uh, actually, it's better to place the value 6 here on the right most or in the right part, because when we regroup those with variable x, we can proceed with completing this square. Yes, you heard that. By completing this square in order to find the standard equation of this general equation. Okay, let's proceed. So our third term there, so that is 4. Sir, how did you get 4? So basically that in getting the value for that's b over 2. So this is b over 2 squared. So our b there is 4. So basically that's 4 over 2 squared. 4 divided by 2, that's 2. 2 squared, that is 4. So that explains the value of 4 there. And after that, we can now transform this perfect square term trinomial into a perfect square binomial. So here we go. So this the root of x squared, it's x, the root of 4, that's 2, and then copy the sign of the middle term for the middle term in our binomial, and then quantity squared. It's equal to, or you can also do the factoring method. So it is equal to 5y plus 10. Sir, yes. Remember the in equation, when you add 4 on the left side, you need to add 4 on the right side. Okay, I need to explain that one for you to be informed. And after that, you perform the operation. Okay, so we can factor out 5 here. So copy the quantity of x plus 2, quantity squared is equal to 5 times the quantity of y plus 2. Therefore, the equation of the parabola in standard form is the quantity of x plus 2 squared is equal to 5 times the quantity of y plus 2. So this is our final answer. Okay, if you want to see the graph, I prepared the graph for this one. Okay, but before the graph, we need to determine first. Yeah, we're not done yet. Determine the vertex, the focus, the directrix, the latus rectum, and endpoints of the latus rectum. It will be very easy for us now since it's in a standard equation. Remember, what's next to s to x will be our h. What's next to the variable, or what's next to the variable y, that will be our k. And the 4p here is located here. The 4p. Equate 4p by 5. Okay, that's what I mentioned to you earlier. So 4p is equal to 5. Divide both sides by 4. You will get p is equal to 5 over 4. Since p is greater than 0, that means the parabola opens upward. Its focal length, so you need to identify the focal length, the absolute value of p, which is also, I'm sorry, which is also 5 over 4. Okay, based from the given, we can now have the vertex, which is negative 2 and 2. Okay, so how did you get negative 2? For our h, as you can see here, h. So this is positive here, so it will be negative 2. And then same goes with here, so it's a positive here, so it will turn into negative 2. For the focus, it will be negative 2. Remember that your focus is aligned with your vertex for the x value. And how did you get the y value, sir, of our focus? Okay, so determining the y value of our focus, it's all because of our focal length. Yes, it's because of the focal length. When you are going to combine your -2 to your focal length, 5/4, so which means you need to move downward 5/4 units. So basically 5/4, that's 1 1/4, right? Okay, so we added 1 1/4 units below. Yeah, that's how you should do it. And for the directrix, y is equal to -13/4 because from your vertex, you need to move 5/4 units ab- uh, above. Yeah, okay. I know. Actually, it's my mistake, guys. The focus here, it should be located above. So you need to move, yeah, uh, 5/4 units above for the focus and 5/4 units below for the directrix. Yeah, I was misconcepted by the opening. So I forgot that it's opening upward, right? Okay, so for the focus, you have it there, -3/4 because -2 plus 5/4 units, so you get -3/4. And then for the directrix, that's from the vertex, you need to also add 5/4 units below. Why did I say below for the directrix? Because the parabola opens upward. Remember that the directrix should always be located on the back portion of the vertex. So you can see it in our graph later on. And then how did we identify the latus rectum, sir? Basically, the latus rectum will always pass the focus, so we use the y variable for the latus rectum. Okay, and how will we find the endpoints of the latus rectum? It is shown here in finding the endpoints of the latus rectum. Okay, it's a detailed solution. Okay, you can pause the video and take note for the detailed solution. And we will get 1/2 and -3/4 and -9/2 and -3/4. So let me show you here. Okay, this is how the graph looks like. Yeah, it's very wonderful, right? Okay. Anyway, so the graph should look like this. It's opening upward. You have here the ends of the latus rectum. And then you have here the focus and you have here the vertex. Let's proceed. Example number 3. Determine the equation of the parabola given the focus 3, 1 and the directrix y is equal to 6. Okay, as you can see from our given, the only given there is the focus, which is 3/1, and then the directrix, which is y is equal to 6. How are we going to solve for that one? Okay, since, okay, it was shown here. Our y value is equal to 1. We can substitute it to our standard equation. Okay, using the standard equation. But before you can use that one, you can identify already the vertex. Vertex is 3 and 7/2. Sir, how did you get the vertex 3 and 7/2? Yes, for the x value, it's quite obvious because the x value of your focus is the same with the x value of your vertex. And how about, sir, the y value, which is 7/2? Okay. Always remember, guys, that we can use the midpoint formula. Remember that our vertex is the midpoint of our focus and our directrix. Okay, you can use that one. You can check it out by solving it on your own. And for the focus, we have 3, 1, basically from the given. And then the directrix from the given, that's y is equal to 6. And then lattice rectum, basing from our focus, that's y is equal to 1. And in finding the endpoints of the lattice rectum, it is shown here on the right part. That's how we find the endpoints of the lattice rectum. Yeah, it will really take time. Sir, I have a question. Is there another way in solving the focus? The answer there is yes. Or finding the vertex, the answer there is yes. Because the vertex here, as you can see, we have another way of solving that one. Okay. And in solving that one, you need to graph the points accurately. And then you need to count the units also accurately. That's the other way of solving for the vertex first. Yes, I'm giving you here some tips. Next. So this is how the graph being shown. So as you can see, 3 and 1 for the focus, and vertex is 3 and 7 over 2, which is 3.5. Yeah, they are just the same. I'm using for the Desmos graph to accurately graph the equation we have. And then for our endpoints of the lattice rectum, which is -2 and 1, and then 8, 1. Therefore, this is the graph. Okay, now let's proceed to our fourth example. How about if the given now is basically we're dealing with horizontal. And I'm sorry, we're with vertical, right? Now, how about if the given here is a horizontal equation? Yes, this is the standard form of a horizontal parabola because the y here is being squared. So, given y minus 4 quantity squared is equal to a times the quantity of x minus 5, find the vertex, focus, directrix, lattice rectum, and endpoints of the lattice rectum. Okay, for the solution, it's very detailed here. Given the equation above, we can say that this is a horizontal parabola. Yes. Determine the value of p so that we can identify whether the parabola opens to the right or to the left. Equate 4p by 8. Yes, as you can see, the position here, it's 8, and that's our 4p. So we have 4p is equal to 8. Divide both sides by 4 to find the value of p. And then 8 over 4, that's 2. So p is equal to 2. Since p is greater than 0, therefore, the parabola opens to the right. And its focal length is 2 by finding the absolute value of our p. Okay, based on the given, we already have the vertex. Okay, here, the vertex 5 and 4. Focus, that's 7 and 4. So how did you get 7? Since the vertex is 5 and then you add 2 points because the focal point is 2. 5 plus 2, that's 7. And then copy the y value for the vertex, which is 4. And for our directrix, since it's opening to the right, so you need to move also to the left for the directrix. So from 5 moving to the left, so that's 5 minus 2. So you will have x is equal to 3. And for the lattice rectum, that is x is equal to 7, basing from the x value of our focus. Because always remember that the lattice rectum will always pass the focus. And in solving the endpoints of our lattice rectum, it is being shown here in the right mouse or in the right part. Yes, you can pause this one and observe how did we solve it. Okay, and this is how you are going to see the graph. Basically, let's check 7, 4, that's for the focus, 5, 4, that's for the vertex, and 7, 8, and 7, 0, that's for the two endpoints. Yeah, that's correct. So this is the violet here is yeah, that is uh, x is equal to 3. Okay, let's count. 1, okay, as you can see here, 1, 2, 1, 2. Yeah, because the focal point is 2. From your vertex, 1, 2. That's 2 units from the vertex. Okay, and that's we are going to solve parabola given a horizontal parabola or a horizontal type of equation. Okay, how about example number 5? Consider the equation 2y squared minus 10x plus 8y minus 12 is equal to 0. So this is a general form of yeah, this is a horizontal horizontal parabola since our y here is being squared. Put this equation into the standard form or convert the general into standard. So basically we are going to apply there completing the square. Always remember, if the given is in a general equation, in converting that into a standard form, we apply completing the square. So where can we see the completing the square? Completing the square is located here. You can only proceed completing the square when your first term, okay, look at that one. Your leading coefficient should be 1. Okay? Since our first term has a leading coefficient 2, you need to divide all the equation by 2. So you are going to get 1 as a remaining leading coefficient. So 2y squared divided by 2, that's y squared. Negative 10x divided by 2, that's negative 5x. And then 8y divided by 2, that's 4y. Negative 12 divided by 2, that's negative 6. And then equal to 0. You regroup them. So we can regroup here y and y. So y squared plus 4y is equal to 5x plus 6. Sir, what happened to negative 5x? Why is it turning into a 5x? It's all because you are adding here 5x. And then you are adding here 5x by addition property of equality. Next, since you cannot find the perfect square binomial of this expression, the root of your y squared, that is y, the root of your 4, that is 2, copy the sign of the middle term, which is positive, and then you square them. And after that, 6 plus 4, that is 10, 5x plus 10. Now you factor out 5. Therefore, the equation of the parabola in standard form is the quantity of y plus 2 squared is equal to 5 times the quantity of x plus 2. Next step, you need to equate your 4p. Where is our 4p here? The 5, that's our 4p by 5. 4p is equal to 5. Divide both sides by 4. And then your p will turn into 5 over 4. Since p is greater than 0, that means that the parabola opens to the right. Yes, greater than 0. Take note. Its focal length by finding the absolute value of your p, that's 5 over 4. And based from the given, we have the vertex negative 2, negative 2. Okay, here, negative 2, negative 2. Sir, why is it negative 2 and negative 2? I can see here y plus 2, x plus 2. It's all because the standard equation, you need to familiarize. It's y minus k here, and then x minus h. So that's negative 2, negative 2. And for the focus, for the y variable, the same y variable for your vertex and for your focus. And then for the x variable, you need to uh, combine the focal length. Since it is opening to the right, so the focus will be plus, okay? Negative 2 plus 5 over 4, that is negative 3 over 4. Next. Sir, is 5 over 4 a bigger value than negative 2? Basically, uh, yes, it's a bigger value, but when you add them, it's negative 2 plus. When you add them, it should be positive because we're using the absolute value. I'm talking about the units, okay? So let me emphasize that one. So let's say here. So this is negative 2, right? And then 1, 2, 3. So basically, from negative 2, you need to move, okay, since the parabola opens to the right, okay, so the parabola is opening like that. Okay, from here, you move to the right also. So that's 1, and then 1 and 1/4. So basically, it's here. Okay, it's located here for your focus. That's just an assumption for the graph, okay? It's not the accurate graph I was showing. And for the directrix, that's the opposite. Okay, you move to the left. From the vertex, you move to the left. 5/4 units to the left. Okay, let me show you it here and again. So let's make another graph. And let's say we have the vertex. So okay, let's graph it accurately. So -2 and then -2 that's below. So we have here the vertex, okay? And then we need to move 5/4. Okay, let me have an assumption of the graph. Okay, so basically this is the graph. Okay, we have 3, -3, -4. We need to move 5/4 units to your left. Okay, this is your vertex. You move 1 and 1/4. So that's 1 and then 1/4. So basically, your directrix is located here, mhm, at the back of the graph of the parabola. Yes. Now, for the latus rectum, so basically you're going to base the latus rectum from your focus. Since this is a vertical parabola, you need to check the x value. So the x value here is -3/4. Therefore, our latus rectum will passes through x, which is equal to -3/4. And in solving for the ends of the latus rectum, all you need to do there is to look at the detailed solution here. We substitute the value of x, which is a -3/4, to your standard equation again. As you can see it here, and then here, observe. Okay, the same process will happen, guys. And then for the graph of this given, for this example, I want you to graph it on your own. So basically, you can use Desmos if you want to. Okay, so this is our example number 5. And let me end in example number 5 because for the next example, I want you to answer it and study it on your own. Okay, thank you so much, guys, for listening actively, for also watching and observing how we did the graphing and how we solved the horizontal and vertical parabola. Goodbye.